Number 8. You explode! You've probably seen it in your favorite space movies, or at least heard the tale. A man in space is forced out of the spaceship or rocket into the open galaxy without protective gear. Within seconds, he explodes into a million pieces under the pressure of the vacuum powers of space. But does this really happen? To be honest, you would die in space, but not for the reason you think. Instead, it would most likely be the simple lack of oxygen. No breathable air equals no humans. That and abolism. Abolism is the formation of bubbles in the body fluids that occur when we don't have the ambient pressure that we're used to. These gas bubbles in your body are no good, and you can swell up to a frightening size, but you will not explode. Unless you got some serious skin tightening surgery perhaps, as your skin is naturally stretchy. How do you think a woman's stomach grows when she has a baby? Yeah. But more than likely, the lack of oxygen would kill you very quickly. In a few seconds, you'd lose consciousness. Unlike when you're underwater, when in space, the lack of Earth's pressure may cause your lungs to go haywire if you were to hold your breath and let that air try to escape. After that, you'll still last a couple of minutes before peacefully passing away in your state of unconsciousness. Though that abolism thing may sting a tad, or a whole lot. I'm not really sure. I've never been to space. Number 7, you become weightless. Despite what you may believe, astronauts are not completely weightless in space. Gravity is only 10% weaker at the International Space Station than on the Earth's surface. But weightlessness is relative. It can be said that any object that is falling freely is weightless, no matter where it happens to be. So, in space, astronauts simply feel the sensation of being weightless. Imagine you're riding a roller coaster and you reach that spot where you lift up out of your seat for a second. That's about what it's like to be in space. Only in space, it's more constant. So, in reality, the weightlessness in space isn't because there's no gravity in space making them literally not weigh anything. It isn't because the vacuum of space zaps away any gravity or takes away the air resistance. It isn't even because the astronauts are far from Earth where gravity is no longer relevant. People say the absence of air has an effect, but air pressure and gravity aren't as related as you may think. Besides, the force of gravity can penetrate through space itself, but the force of gravity is not affected by air pressure. So there's no air pressure, but the gravity in space isn't zero. The real reason is that there is no external contact force pushing or pulling their bodies. That's it. It's not some weird timey-wimey space thing, just earthly science. You dig? Number 6, it's always freezing. This one is totally ridiculous, but many people believe that space is always cold. Some think space holds freezing temperatures no matter where you go, but in reality, it's far from it. Again, it's all relative here. Some parts of space are so hot that they literally reach millions of degrees. Temperatures so high that we literally can't even begin to imagine what it would feel like. This is because before we had a chance to even realize it, we'd be blasted out of existence. On the other hand, there are places that can reach 455 degrees below zero. Fahrenheit, that is. So, how is this decided if the range is so broad? Well, the gas in space is generally too thin to be of use on those cold space nights. Heat in your body may radiate away very quickly without its help. This is in the shade. When the sun hits you, temperatures can scorch you in no time. Sure, there are drastic extremes depending on location. With a different setting, conduction, convection, and radiation are totally different in space. But in space, the Earth's distance from the sun is a fairly comfortable, depending on who you ask, 45 degrees Fahrenheit. Number 5, the sun is on fire. No, no, no. I hate to break it to you, but the sun is not on fire. What? Crazy, I know. You may imagine a flammable ball that catches on fire like paper dipped in kerosene, but that's not our sun. When paper is caught on fire, The carbon, hydrogen, and oxygen combine with molecules of oxygen in the atmosphere to create carbon dioxide and water. This compound releases heat and light, and this reaction is known as combustion. But the sun doesn't use combustion, but rather nuclear fusion. Every second, the sun converts 700 million tons of hydrogen into 695 million tons of helium. This conversion creates gamma rays that reach the Earth as light. The temperature of the sun is about 28 million degrees at its core, but is not on fire as we know it. So, in short, it is burning, but it's not on fire. Sorry to burst your bubble. Obviously, our concept of fire is much different than what the sun is producing. In fact, if there was life on the sun, the inhabitants would probably think that what we see as fire is simply a different form of burning, a different chemical reaction. They would also think that our fire is freezing and would truly freeze to death in a way if coming into contact with it. Again, that's just saying if there was life on the sun, which is crazy, right? Hold up, real fast. If you're new to checking out the channel, welcome. Go ahead and give this video a like and hit that subscribe button if you haven't already. Number 4, the sun is yellow. All those years of coloring your pretty landscapes with a yellow sun have been all wrong. So what color is it? Orange? Nope. Red? Nope. White? Nope. Just kidding. It's white. But not in the way you think. The sun is actually all of the colors mixed together, which is essentially what we see as white. To put it into perspective, take a look at a rainbow. A rainbow is actually the light from the sun with all of these colors. The difference is that the rainbows are separated versions of the colors of the sun. Cool, huh? Imagine you have a box of crayons. You take all those crayons and melt them together. This is pretty much the opposite of what happens when rainbows are formed, except instead of that unappealing brownish purple color, you get white. Each of the colors of the sun and the rainbow has a different wavelength, with red being the longest and blue being the shortest. So when we see the sun on the horizon, the shorter wavelengths are scattered out by the atmosphere, so only the longer waves, such as red and orange, are visible. In fact, this is the same reason that the sky is blue. In a way, those short wavelengths reflect and bounce off the atmosphere to reveal a blue sky. Who knew? Number 3, the moon causes tides alone. Some people think that tides are caused by the gravitational interaction between the Earth and the moon alone. They say that the gravitational attraction of the moon causes the oceans to bulge out in the direction of the moon. While this is true, that pull isn't strong enough to create the world's largest tides. That's because tides are not simply caused by the gravitational pull of the moon. The moon doesn't exactly revolve around the Earth, but they both revolve around the center of gravity. But the Earth is a lot heavier than the moon, so it travels in smaller circles. It is partly this movement that causes the oceans to move around like a little kid walking with a bowl of milk and cereal. You can see the milk sloshing around, right? This means that even lakes are very slightly affected by this, but it's not noticeable. So the flow of the river is more drastic than the tides of the river, so the tides are canceled out. Again, the tides are in part caused by the bulge of the pull of the sun and the moon. As the Earth rotates, the water is pulled and pushed, causing tides. But despite misconceptions, it's not the only reason. Number 2, asteroid belts are dangerous. You're flying through space when you come upon an asteroid belt. The asteroids are flying at you at an alarming speed. You must use the lasers your ship is equipped with to shoot them before they crash into you, ending the life of everyone on board. Yeah, that's only seen in the movies and the video games. It's more likely someone in the forest will run into a tree and die than it is for someone in an asteroid belt to get hit by one of those guys. Asteroids in asteroid fields are really far apart and very tiny. It's kind of like driving on a gravel road and a rock hitting your windshield. More often than not, hundreds of miles are between them, and they're usually no bigger than a tennis ball. So this is one of the least likely ways an astronaut will die. It's more likely they'll choke on space food. So while in our solar system, asteroid belts are harmless, it does make you wonder if there are sci-fi-like asteroids out there somewhere. The odds of hitting one in our system are 1,000,000,000 to 1. But you never know. Some otherworldly Han Solo could be out there right now fighting for his life. Number 1. Meteorites aren't hot. Imagine a meteorite just flew through the air and you immediately went to check it out. What do? Touch it? Pick it up? Probably not. Due to movies and other outside influences, we've been taught that meteorites are dangerous, smoking objects not to be messed with. Sure, as they hit the atmosphere, the surface begins to heat up. But then, that surface begins to strip off because of the heat as the meteorite falls through the atmosphere. Anyway, when they left space, they were rather cold and would take a lot of heating up to get rid of that cold temperature. Although there have been reports of hot meteorites, it is likely they were exaggerations, and unfortunately, not enough scientific evidence has been collected to prove their temperature either way. But we do know for sure they aren't fireballs nor ice cubes when they land. More than likely, they're a pretty comfortable temperature. The process that happens as it flies through the air is actually the perfect cooling and heating method. Still, it definitely depends partially on the speed and certainly the size of the mass. It could be slightly cool, or it could be slightly warm. Thanks for watching. What did you think of these common myths about space? Did you know any of them before watching this video? Let me know in the comments below. And don't forget to subscribe for more videos like these. I'll see you next time. Bye.